Lunch break, doing math again. So you're supposed to rewrite and simplify this logarithm. Your rules are over here. This 2 goes here, becomes a natural log of 6 squared, which is a natural log of 36. I'm going to bring this one down, plus the natural log of 4. Then I'm going to pay attention to this one. If I read it from right to left, it tells me I can multiply things together. It's a single natural log with the product of 4 and 36 inside of it, which is 144. That's how you do those. You look at these properties and you do them. All right. This is the old school way. The ACT still does this stuff. They'll give you some values up top and they'll ask you to evaluate it using these numbers, okay? So the log of 1 over 3, what you have to do is you have to think about how you can take a 4 and a 12 to make a third. I have no idea if these are actually in your notes from class or not, but I don't know. I don't remember. But anyways, you just have to think about how 4 and 12 make a third. Well, it turns out that 4 over 12 is a third. Now, I glance up here at the division rule, which says I subtract. The top one's positive, bottom one's negative. This becomes log of 4 minus log of 12. And it says you have to show your thought process because you could just push buttons on a calculator. It gets you close because these are around a third decimal. Wouldn't be entirely correct. So the answer is going to be 0.602 minus 1.079. 0.398, 0.478, 0.477. Yeah. I should probably be checked on that. I feel like it's right though. 0.477. So that's number 6. 9 is condensing logarithms. And we're going to take this thing with 3 logarithms and we're going to make it one giant, or so just one big logarithm. It's going to have a whole lot of stuff in its argument. First things first, that goes there. That's what happens, okay? This becomes the natural log, and I'm going to rewrite it as all of 2y to the 1/2. That goes there, plus the natural log of an x to the second. That goes there, minus the natural log of a z cubed. And then there's this guy. There's that guy. Somewhere on your formula quiz, you're told that the natural log of e is 1. This is a -3. That means it takes minus 3 natural logs of e to do such a thing. I don't know if that makes any sense to you or not, but that's what it means. Minus 3 ln e, or natural log e cubed, because we move that 3 up top. Now we're in business. We can go ahead and we can do a full condensing here. Anything that's positive goes in the numerator. Anything that's negative goes in the denominator. Positive in numerator, negative in denominator. All right? I'm going to have a single natural log. It's going to have a whole bunch of stuff in it. I'm going to use a hard bracket because there's so much stuff in it. I've got all of 2y to the 1/2 power. I also have an x squared up top. And in the denominator, I have a z cubed and an e cubed. And that is the condensation, or condensing, of that logarithm. Now, I don't think I missed anything. On to 10. Both of these guys are going to get that 2. There's a 2 out front of both. All right, so make sure you understand that. That's going to be log 3 of 20 squared minus log 3 of 4 squared plus log 3 of 4 to the 1/2 power. Then you're going to work with the numbers. 20 squared is 400. 4 squared is 16. And 4 to the 1/2 is the root of 4, which is 2. I forgot the plus. Let me go back over to this rule right here. Positive in the numerator. Let me get over there. There she is. Negative in the denominator. It is a single logarithm of base 3, and the numerator is going to contain 400 times 2. There's a 400 times 2. The denominator is just 16. And this is going to clean up quite a bit. This should be 50. That's 800 over 16, and it is. It's a single log base 3 that contains a 50 in it. And I know you're wondering, like, what? How do you get 50? Because I did the math. I did 400 times 2, and I divided it by 16 without a calculator. It's 50. 13. We got a log of 6x squared over y to the 4th, and we're supposed to completely expand, so it's the opposite of what we did in 9 and 10. And the rules are up here. It's the same thing. Multiplication is addition, division is subtraction. So I'm going to write that down. Multiplication is addition. If you know your exponent rules, these make sense because they're the opposites. Division is subtraction. All right, so when I break this apart, you need to realize there's a multiplier symbol right there. That's a log of 6 times a log of x squared, sorry, not times, plus a log of x squared minus a log of y to the 4th. And I'm sure it says express powers as factors. So like these, that 2 and that 4, they go out front. Log base 6 plus 2 log of x minus 4 logs of y. Logarithms come back with a vengeance in calculus. Like, you don't log into calculus without actually understanding the rules of logarithms. This is the stuff that matters in calculus. Knowing this. And they come back with a vengeance. 14, log base 3 of 3 times the cubic root of x to the 5th times the square root of y. Huh? All right, well, first off, let's just break everything apart. All right? Multiplication is addition. Log base 3 of 3 plus log base 3 of x. And I'm going to do something funky here. If I know my xp over r rule, the power is 5, root is 3. This is to the 5/3. And I talk about square root of y, the understood 2. This is y to the 1/2. So plus log base 3 of y to the 1/2. Almost done. This guy right here. On your formula quizzes, log base b of b is 1. This thing is asking, what power of 3 is 3? If you did the homework from the previous day, you understand that. This is 1 plus log base 3 of x to the 5/3. Oops. Let me restart. Those go out front. Sorry about that. This is 1 plus 5/3 log base 3 of x plus 1/2 log base 3 of y. And that's all I'm going to do for now. I'd like to take a minute break or so before you guys get in here for next period. So, hope you had a good lunch. I did not.